G'day and welcome back. Today we're making some replacement stainless steel spit burners. As you can see, the old ones are past it. There are quite a few interesting features to machine and weld, and so I bought a bunch of 316 stainless, and let's get cracking. Banana coloured tape measure for, scale. Lopping off some of the length. Well, that looks wrong. This stainless really didn't want to turn nicely, but I did make it work. Now to lay out some end caps. First step is to rough out the shape on the saw using the bimetal blade. And because my belt grinder motor is still toast, but not for long, I use the angle grinder to finesse the shape. That was pretty hot. I remember that with eye-watering clarity. Okay, these end caps are done. Now it's time to weld them on. I'm using the TIG, and I'm fusion welding these, which means no filler. This should be pretty straightforward. If at first you don't succeed, second time lucky. Third time lucky? The late great Albert King once said, if it weren't for bad luck, I wouldn't have any luck at all. Yeah, fourth time lucky. Time to press the fleshy welding rotator into service. Using this tool helps roll the tube and get a smoother weld. And here I'm trying to keep the shielding gas on the weld until it's cooled a bit. I'm getting the stainless pretty warm here, and it will only get worse if I don't shield it. After a clean up on the wire wheel, they look like this. I'm happy with those. Now to make some mounting tabs for the ends. If you remind me later, I'll show you how those tabs help with some of my mill setups. Again, I'm sawing and grinding because this project doesn't warrant the precision and setup time for milling. I've tacked those tabs off camera. Please don't mind my bonds blocking the view. It's very important to use the right tool for the job, and here I'm trying out Nipex's new weld straighteners. So the mill spindle is centered over the workpiece, meaning I can use the drill bit to get the burner to the right angle, and then read the angle from the gauge. Now I can see that angle box perfectly. You might not be able to, which means you probably need to adjust your YouTube zoom settings. And now onto the main mission, drilling the holes. If you take any pleasure seeing me work on badly chosen projects, such as this one, drilling 800 holes, 1.5mm diameter, into 316 stainless, well, you know where the Patreon link is. And that drill bit is a bit past it. Which means a trip to the grinding room. I got pretty okay at sharpening these tiny bits by hand, mostly because I had to do it dozens of times. I used up 3.5 drill bits on this job. They only start out 40mm long. You use them up quickly, especially if you snap 2 in the first half dozen holes. This might have been a good job for my little CNC, but I just haven't got it set up yet. And I would drill 500 holes, and I would drill 500 more, just to be the dunce that drilled 1,000 holes so you could burn your food some more ore. To do the second half of the holes, I've got to wind the table back, slide the work along, and align the hole position axially and also the angular position. And this will give me a nice seamless transition. Now to notch out the ends. These match the originals and allow for some air control. I'm finishing on a climb cut to get a slightly better finish. The tube is flexing here though, hence the imperfect cuts. I can clean those up with a file. Marking the grease guard standoff lengths, which I will turn to length off camera. I did shorten the mounting tabs off camera too. Somehow I made them too long. And of course drilling them and countersinking. The guards themselves are just flat bar trimmed to length with the corners taken off. And here I'm marking out the standoff positions. First they get tacked into place with my very ugly third hand welding helper, applying a bit of useful downwards force. And then finishing off with some short round fillets. I'm stopping regularly because it's difficult working around a tiny cylinder. And also I'm trying to let the heat dissipate. Stainless is a very bad conductor of heat, prone to overheating, and honestly I tend to slightly cook my welds at the best of times. So I'm being especially mindful here about heat input. Next up is a threaded hole which will hold the air control collar on and hold it at the right angle. Yes, I am touching off with a drill bit, and no, I will not apologise. Snappy snap snap. Not really, that worked quite well. The thread seems to fit, which is always a plus. That control allows you to balance the air coming in with the fuel going through, and because of the dimensions it should work exactly the same as the original. Now we need to make this Venturi piece. You can hopefully see that it's tapered from both ends, 2 different angles. Turning the OD first, then centre drilling. And drilling a through hole. Working in stainless for me is always tricky, but I've learned a few things on this project, and I've got a bit more confidence for next time. You can probably see a bit of movement in my compound here. In the middle of the job I actually pulled the compound to bits and fixed that gib. I didn't film the fix, but I might include some photos in an update video. By the way, if you don't know, I do put extra videos out on my second channel, Craig's Workshop Updates, links below. These tapered pieces came out well, and they fit in the tube nicely. Off camera, I drilled some cross holes in the burner body, slipping them into place. And then plug welding. You know what they say, grinder and paint, 'cause a welder I ain't. Except this is stainless, and we don't paint stainless, so maybe grinder and Scotch-Brite, 'cause a welder I'm not quite? Clean with some acetone to help keep the welds clean. And here I'm jigging up the parts square and straight, resting them between the square and the angle plate. First tack those into place. I did make a mistake here and got too close to a drilled hole, and the heat enlarged it and opened it up to about 3mm, which was a bit of a sidetrack. Anyway, after that I decided to weld the posts in 2 places and stay away from the holes. I didn't want to make the same mistake again, that could be a big time sink. And that's the finished job. After shooting this, these burners went to their new home and apparently they work great. The old burners were made much more cheaply and from thinner materials, but still lasted 10 years, so this new set should last a good long time. If you liked the video, please subscribe. Thank you to patrons, your contributions really help to make these videos. Don't forget to check out my Discord if you want to chat, and also my second channel for news and behind the scenes stuff. Links below. Thank you for watching.